Hello lovelies, in this video we're going to be going through your AQA AS Maths Paper 2, the paper that we've written for 2024. So what I want you to look at is how we've laid out the answers, what sort of things the examiner might be looking for if this was the question that came up, and then take that and apply it in your own revision.
The annual profit made by a small company selling a unique gift is modelled using this equation. P equals minus 7 over 2x squared plus 63x plus 2000, where P is the profit in thousands of pounds and X is the number of gifts sold in hundreds of thousands. The company wants to work out the maximum profit they should expect to make. Here we're asked to find the maximum profit and the number of gifts sold to give this amount of profit. And there's two methods we can use here. Because this is a quadratic equation, quite commonly we'd have to do this by completing the square. However, because we're talking about maxima, we could also differentiate. Now that's going to be the method that I choose here. However, both are solid and quite often we will have to complete the square. It depends on what information we're given. So if we say that dp dx will equal 0, let's have a look at differentiating these one at a time. So remember, to differentiate, we multiply through by the power and then we subtract 1 from the power. So therefore, when we differentiate minus 7 over 2x squared, multiplying through by the 2 just gives us minus 7, subtracting 1 from the power just gives us x. 63x just gives us 63 when we differentiate it, and we just drop the x, and 2000 just goes to 0. So here we have minus 7x plus 63 equals 0 because it's a minimum, which rearranges to give us x is equal to 9. Now that is the number of gifts. However, it's not 9 gifts, we can't end there. We have to remember looking at the units, and in any problem solving sort of modelling type question, please do go and look at the actual units. We need to multiply through by 100,000. So actually 900,000 gifts would be sold to get this maximum amount of profit. So now we know the corresponding value of x that will give us this maximum value. Let us now substitute this in to work out what the profit is when we sell 900,000 gifts. So we know that the profit is equal to minus 7 over 2x squared plus 63x plus 2000. If we substitute in that value of x equals 9, because of course remember in this equation x is just the 9, not the 900,000, we get p equals minus 7 over 2 times 9 squared plus 63 times 9 plus 2000, which ends up giving me p is equal to 2,283.5. However, looking at this, we know that profit is in thousands of pounds. So that means that we need to multiply this p value through by 1,000 to get the profit in pounds. So times it through by 1,000 and we end up getting £2,283,500. And that there is our answer to part A. If the company wants to make a profit of £100,000, find the minimum number of toys that must be sold. So here we need to use our equation for P again. So remember that the profit was in thousands. So that means that P is equal to 100 when we substitute it back into the equation. So let's start just by reminding ourselves of that equation again. We've got P equals minus 7 over 2x squared, and then that is plus 63x plus 2000. So if we want to know what x is when the profit is equal to 100,000, or p is equal to 100, we just substitute that in, and then we're going to have to solve it for x. And you can do this either in a completed the square form you might have got in A, or just using the quadratic. It will work either way. So if we subtract 100 from each side, then we get that minus 7 over 2x squared plus 63x plus 1,900 equals 0. So now we can solve this. It's a quadratic equation, so we could factorise it. However, maybe this would factorise, maybe it wouldn't. It does not look easy to do. I certainly wouldn't try. I would just get straight to the quadratic formula. So remember, quadratic formula states that x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. I always like to lay out first what my a, b and c is first because, gosh, it's easy to make mistakes. So a is the coefficient of x squared, which is minus 7 over 2. B is the coefficient of x, which is 63. And c is the number all on its own, and that is 1900. So now we know this, we can make the substitution into our formula. X is equal to minus 63, plus or minus the square root of 63 squared, minus 4 times by minus 7 over 2 times by 1900. And that's all over 2 times minus 7 over 2. So when I first put that in with the positive value, I get minus 15.977. And then when I put it in with the negative value, I find that x is equal to 33.9771324. Now, x is the number of toys, it can't be negative then. So x must be corresponding to that 33.977. However, remember that x equals that, the x is the hundreds of thousands of toys. So to actually get the number of toys sold, let's multiply this through by 100,000. So doing that, we end up getting a very large number of toys. We end up getting 3,397,713. And that is the number of toys that we must sell to make a profit of 100,000. So in C now, we're asked to suggest why this model may not be suitable to model the profit from selling these unique gifts. So there's often a lot of things we could say here. However, there are often statements that we can carry on into other similar questions. Now in this case, I would state that one of the issues with this model is that if you look at it, the p equals minus 7 over 2 x squared plus 63x plus 2000, even if x was equal to 0, it would suggest that they would still make a profit. Now, that surely can't be the case, can it? So that would be a reason why this model is not suitable, because even if no gifts were sold, a profit would still be made. So that's a good thing to look out for in any similar questions that you encounter in your exam. Here we're asked to prove from first principles that the derivative of 3x squared is 6x. Now the fact it's 6x is irrelevant here. What we need to do is to know that when we need to prove something from first principles, found in the datasheet is this equation, which states that f dash x equals, in the limit where h tends to 0, f of x plus h minus f of x all over h. And I don't like to rush these, okay? I like to start just by writing out what I know. F of x equals 3x squared. Really obvious. But now I'm going to write down what f of x plus h is. So to do this, I'm going to replace the x in 3x squared with x plus h. That gives me 3 of x plus h squared, which is, of course, 3x plus h times x plus h. So let's multiply out these brackets now. So 3x times x, x squared, plus x times h, xh, plus x times h again, so xh again, and then plus h times h, so plus h squared. And of course that's all still times by that 3. I didn't want to do it all at once because that runs the risk of us making a mistake. So here we have 3x squared. We've got xh plus xh, which is 2xh, which we then times by that 3 and get 6xh, and then plus 3h squared. So now we know what f of x is, and we know what f of x plus h is, all simplified. Remember, I don't like to rush this, let's do that first. But now I'm going to substitute it into our first principles equation. So here we have f dash x equals, in the limit where h tends to 0, in place of the f of x plus h, I'm going to put in 3x squared plus 6xh plus 3h squared, and then I'm going to subtract f of x, which I know is 3x squared. So I'm going to subtract 3x squared. And that's all going to be divided by h. So now looking at this, I can simplify. I've got 3x squared minus 3x squared. They're going to cancel away then. So rewriting this, I have f dash x equals, in the limit where h tends to 0, 6xh plus 3h squared all over h. Let's divide through by that h then, and that gives me, in the limit where h tends to 0 again, just 6x plus 3h. Now, because specifically we're looking at h tending to 0, that's going to affect the 3h part. It's not going to affect the 6x. But if h is tending to 0, and 3 times 0 effectively is just 0. So really here, this leaves us with f dash x equals 6x. And so we have shown that the derivative of 3x squared is 6x. Find the coordinates in terms of c of the minimum point on the curve being y equals x squared plus 5x plus c, and we're asked to fully justify our answer. Let's remind ourselves, whenever we're asked to find a minimum point, we can use the fact that dy dx equals 0. Let's remind ourselves of how we differentiate something like this. If we have something of the form y equals x to the n, then to differentiate we multiply through by the power and then subtract 1 from the power. So dy dx is n x to the n minus 1. So let's do that here. If we start with x squared, we can see that the power is 2, so let's multiply through by that power, and then subtract 1 from the power, and so 2 minus 1 is just going to give us to the power of 1. So here we get just 2x. So now looking at the 5x to differentiate, I can see that will just go to 5. Now the reason for this is, of course, x on its own is just x to the 1. Now if we multiply through by that 1, we're left with 5. And then if we subtract 1 from the power, we just have x to the 0, which is just 1. So the x's just go away. However, I would say to get truly fluent at maths, you should recognise that anything that is just something x, the x will just go away when you differentiate it and you're just left with that constant. So that's what's happened here. 5x is differentiated just to 5. So now let's have a look at differentiating the plus c. Now that's just plus a constant. That could be plus 2, minus 2, plus 1,000, whatever, it's all the same, okay? And again, we could sort of think through the fancy method and stuff, but we should really know that whenever we differentiate a constant, it just goes to 0. So in this case, when we differentiate c, it's just going to go away. So now we've differentiated, and because we're looking at a minimum, we can put this equal to 0. Now rearranging this, that gives us that x equals minus 5 over 2. So now we know the x-coordinate of this minimum point. However, see here, we're not asked to find the x-coordinate, we want the coordinates. So we need both the y and the x-coordinate. Now to get the y-coordinate, we're going to go back to our original equation, x squared plus 5x plus c, and we're going to substitute in minus 5 over 2. So that's what I've done here. As you can see, I've got y equals minus 5 over 2 squared, don't forget your brackets, plus 5 times minus 5 over 2, and then plus c. And simplifying that together, I end up finding that y is equal to minus 25 over 4 plus c. Now those are our coordinates of this minimum point. Don't worry about the fact there's a c in there. Remember, this question said in terms of c. So in order to fully justify our answer at the end, I would just check that we do indeed have a minimum point. Because technically what we found is where a stationary point is. It's not necessarily a minimum. we should know that the minimum is found when the double differential is bigger than 0. So if we differentiate again, this time differentiate 2x plus 5. The 2x differentiates just down to 2. Remember all those x values, when we differentiate them, the x just goes. The 5 will just disappear when we differentiate it, just like any constant. And so we just find that that double differential equals 2. And indeed, 2 is bigger than 0. So what we have here is a minimum. Here we have a proof question. A student suggests that the sum of the squares of 4 consecutive positive integers can always be divided by 3. For example, 1 squared plus 2 squared plus 3 squared plus 4 squared equals 30, which we can divide by 3. Here we're asked to show by counterexample that this suggestion is false. Now, counterexample means just come up with some options where this doesn't happen. So I'm going to try the next set of consecutive numbers. So rather than starting at 1, I'm going to do 2 squared plus 3 squared plus 4 squared plus 5 squared. Now, popping those into the calculator, I get 54. If I try dividing that by 3, I get 18. So at the minute, I'm proving that it can be divided by 3. Let's try another one then. Let's try 3 squared plus 4 squared plus 5 squared plus 6 squared. Popping that into the calculator, I get 86. Again now, I'll just try dividing that by 3. Again, just use the calculator. And I end up getting an answer of 28.66666. Now the fact that isn't a whole number shows that we cannot divide it by 3, and therefore we've shown by counterexample, by finding the exception, that this suggestion that this will always be able to be divided by 3 is false. So remember, counterexample just really means by contradiction and by finding the exception. So now we're asked to prove that the sum of the squares of the 4 consecutive positive integers, so the same thing we were talking about in part A, can always be divided by 2. So we're still looking at a similar concept, but this time we're showing it can be divided by 2. Now, in algebra, we can represent 4 consecutive positive integers by n plus 1, n plus 2, n plus 3. And because we need the sum of the squares of these 4 consecutive positive integers, that's n squared plus n plus 1 squared plus n plus 2 squared plus n plus 3 squared. And to prove this, we just need to simplify this algebra, tidy it up, and see what it looks like. Now, the key place where people will make a mistake here is they'll look at n plus 1 squared and just say n squared plus 1. But remember, every time you square a bracket, it's the bracket times by the bracket. So here we've got n squared plus n plus 1 times n plus 1, plus n plus 2 times n plus 2, plus n plus 3 times n plus 3. And so we're going to have to do all of that multiplying out. So here we get n squared plus n squared plus n plus 1 times n plus 1 times 1, 1. On to the next set of brackets. So plus n times n squared again, n times 2, 2n, plus 2 times n, 2n, plus 2 times 2, 4. And the final bracket now, n times n is n squared again, n times 3 is 3n, 3 times n is 3n, and 3 times 3 is 9. A lot of information there, but we just need to tidy this up now, okay? So let's get our like terms together. We've got n squared plus n squared plus n squared plus n squared. So we've got 4n squared. Now let's take a look at the n's. So we've got n plus n, so 2n, plus another 2n, 4n, another 6n, another 9n, and then another 3n is 12n. So we've got 4n squared plus 12n at the moment. Now finally, just the units on their own, we've got plus 1, plus 4 and plus 9, which gives us plus 14. Now we need to show it can always be divided by 2. The way we can do that is by taking out a factor of 2. So we're going to say 2 and then brackets 2n squared plus 6n plus 7. And the fact we've got that 2 outside the bracket, all of these have been factorised out by that factor of 2, shows us that it is divisible by 2. And that is our proof done. Here we need to solve the equation 6 cos squared theta plus sine theta equals 4. And we're asked to give all values of theta between 0 degrees and 360 degrees. So the first thing we need to do is to identify which equation to use. And at AS we only know two. We know that sine squared plus cos squared equals 1, and we also know sine over cos equals tan. Now, the one that's relevant here is definitely going to be sine squared theta plus cos squared theta equals 1. Because if we look at the equation that we're given, the issue is that we've got a mixture of coses and sines. However, if we rearrange our identity, then we can remove all the coses and just get it in terms of sines. And the bonus there is it's going to be in the form of a quadratic that we can easily solve. So let's start by just rearranging the identity. Here we can say that cos squared theta equals 1 minus sine squared theta. So now that we've done that, let's substitute this in. So in place of cos squared, we're going to put 1 minus sine squared theta. So here we have 6 brackets 1 minus sine squared theta plus sine theta equals 4. So now we've done this, let's multiply out those brackets. So here we've got 6 times 1, which is 6. 6 times minus sine squared, which gives us minus 6 sine squared theta, plus sine theta equals 4. So now we've eliminated all the causes, we just have it in terms of sines now, which means that we're able to solve it. Now looking at this, I can clearly see I've got a quadratic equation. So let's get it now so everything is on one side, preferably with a positive squared. So moving them over to the right hand side, I've got positive 6 sine squared theta minus sine theta, and then subtracting the 6 gives me minus 2 equals 0. So now what I've got is a quadratic equation, and I can factorise this. Now hopefully you don't find factorising equations like this too tricky, but let me show you a little technique to do it. So we know that there's going to be sine thetas in there. However, working out how many for each sine theta and what number goes next to it can be a bit tricky. Now, with enough experience, I can see here that this is going to be 2 sine theta plus 1 times by 3 sine theta minus 2. But you're not all where I am, okay? You're learning. So let me show you a method to factorise this. So I'm going to write out the equation again here. And what I like to do in these questions is look at the coefficient of the squared and the number all by itself, and I'm going to multiply those together. So multiplying 6 and minus 2 together, I get minus 12. So what I'm now going to try and do is find a pair of numbers that are going to multiply together to make this minus 12, but that will add together to make the coefficient of just sine theta, or x, which is minus 1. So we need two numbers that multiply together to give us minus 12, that are going to add together to make minus 1. So thinking about that, I can think that minus 4 and 3 would work well for that. Now, these numbers are really important because when we do our double brackets, they're going to be two of the numbers that we put in those double brackets. So let's write out our brackets then and put them equal to 0. So I'm going to put minus 4 and plus 3 in there. And where we're going to put the signs, or x's, dependent on the question, because it's 6 sine squared, I'm going to just put 6 sine theta in both positions. Now at the minute you might be thinking this makes no sense, but remember this is a little trick for you. So now I look at the first bracket, I see 6 sine theta minus 4. I look for a common factor between the two. I know that I can divide each of those by 2, and so I do that, and I get 3 sine theta minus 2. Now I do the same on the second bracket. I've got 6 sine theta plus 3. I know that I can divide both the 6 and 3 by 3, and that gives me the bracket of 2 sine theta plus 1. So now we've fixed any of those weird issues that you might have thought of, and we've got our double brackets, and you see you've got exactly the same as I found just by doing it using lots of practice. That's a really helpful trick that you can use. Now we've done that, we've got it factorised, we need to get back to solving this equation because of course that is what we need to do here. So remember, when you've got double brackets are equal to 0, what we can do is set each of those individual brackets equal to 0 and then solve them. So if we start off with the first bracket, so we can say that 2 sine theta plus 1 is equal to 0. Now if we rearrange that, we find that sine theta is equal to minus 1 over 2. So doing inverse sine on your calculator, please make sure your calculator's in degrees because that's what the question's talking about. That's our most common mistake. That gives me theta equals minus 30. Straight away I notice that isn't within the range that we need, so that doesn't actually count as a solution. What I like to do is I like to draw a sketch of the curve. And we were looking at when sine theta equals minus a half, so I'm drawing a line at about y equals minus a half there. Now you can see where it cuts the curve, and you can see where that minus 30 is. However, you can of course see that there's other points where it cuts that curve. And due to symmetry, I can see that the first point is going to be 30 bigger than 180. Likewise, I can see the next one is 30 less than 360. So here then I can say that theta is equal to 210 degrees and 330 degrees. And there's our first two solutions here. Next up, we need to have a look at the next bracket, which is 3 sine theta minus 2. So 3 sine theta minus 2 equals 0. Let's rearrange this now to get sine theta equals 2 over 3. So if we go back again to our curve and we draw a horizontal line at about the point where the y-axis is 2/3. I can see that it hits it at 2 points. So when I put it into my calculator, the first thing I get will be that first point, and I make that to be 41.8 degrees. So that's our first point. Then using symmetry, I can see that that second point comes in by 41.8 from 180. So I can determine it by doing 180 minus 41.8 degrees. And that gives me my next point, my final point, of 138.2 degrees. So now we have got all 4 possible solutions here: 210, 330, 41.8, and 138.2. I would say that if you've got different answers, one of the main places where you make mistakes, and I've mentioned this before, is just by putting your calculator in radians rather than degrees. We all do it. I sometimes do it too, and I think, why does that look wrong? Oh, radians, that's always my first thing that I check. So always be really conscious before you put the values into the calculator. What is it that the question wants? Is it degrees or is it radians? And then just check your calculator is in the correct setting. Given that the integral of 6 root x between the limits of k and 1 is equal to 28, we're asked to find the value of k. So here, looking at this integral, the k on the top and the bottom tells us the limits of our integral. So we need to integrate between the limits of k and 1, where k is an unknown that we need to find. So first thing we need to do, we can't just integrate root x. We have to rewrite that as x to the power of a half, so make sure you're confident with that. So remembering the general rule of integration, if y equals x to the n, you add 1 to the power, and then you divide by that new power. So let's put that into practice here then. So if we need to integrate 6x to the power of a half, we need to add 1 to that power, giving us 6x to the 3 over 2, and then divided by that new power, which is going to be 3 over 2. So you can do it in little steps. Of course, probably you're just going to be doing it like I just said there, going straight to the 3 over 2. Just be careful because it's fractions. So 6 over 3 over 2 gives us 4. Feel free to use the calculator to do that, just get it right. So that gives us 4x to the power of 3 over 2. And we've integrated that now, but we need to put in those limits still. K on the top and 1 on the bottom. Now what we do when we substitute those limits in is you substitute in the upper limit first, and then you subtract the integral with the lower limit substituted in. So here we end up with 4 times k to the power of 3 over 2 minus 4 times 1 to the power of 3 over 2. And the question told us that was equal to 28. So simplifying this now, that gives us 4k to the 3 over 2 minus 4 equals 28. So if we add 4 to each side, just to rearrange this, I get 4 to the power of k over 2 equals 32. Now if we divide through by the 4, we get k to the 3 over 2 equals just 8. So now we need to get this all on its own, this k. First thing I would do is I would square both sides to get rid of that over 2 in the power. Remember that the numbers on the bottom of the fraction tells you what root you have. So to get rid of a square root, you square. That gives us k cubed equals 64. So now to get rid of cubed, you're going to cube root. So the cube root of 64 is 4. And so our answer to this is k equals 4. The population of rabbits on an island was investigated. The population was recorded each year. The graph of ln r against t is shown below, where r is the population of rabbits and t is the time in years from 2020. So you can see on the y-axis is ln r, on the x-axis is t in years, and a researcher suggests the model r equals a e to the kt, where a and k are constants. Now, part A wants us to find a and k. Now let's start off just by writing out that equation again. I can see I have a straight line here. Now the way that we can change this exponential curve into a straight line is by taking logs or lns of each side. Now, the way in which this is going to work is if we use one of our log rules, the one that states that ln AB equals ln A plus ln B, what we can do is we can see that when we took lns of both sides, we have ln A e to the kt. So we can separate that into 2 different parts. This leaves us with ln r equals ln A plus ln e to the power of kt. So now looking at this, there's another rule we can use. We can use the log power rule. Now this states that log of k to the power of x is equal to x times by log k. Or you could use lns instead. Remember, ln is just natural log, it's still the same. So what we can do the same here, we can say that that kt is the power. So if we just bring it around the front, then we've rewritten it in a great way there. So let's do that. Ln r equals ln a plus kt ln e. So now we're getting close now. We should recognise that ln and e are opposites of each other. Ln is actually log base e. So for that reason, when we put ln and e next to each other, they just cancel out. It's a bit like timesing by 2 and dividing by 2. We've done the opposite. So that just goes away because it's equal to 1. And that leaves us with ln r equals ln a plus kt. Now if we compare this to y equals mx plus c, where the y would be our ln r and our x would be our t, we're going to really be able to make a lot of progress now. So by making this comparison, we can see then that the gradient, which is multiplied by the x, is comparative to the k, which is multiplied by the t. Likewise, the y-intercept, which is all on its own, is ln a in this case. And we can use these facts to interpret this data. So we know that the y-intercept, which is c, is actually equal to ln a. So if we go to the graph now and see, well, where is that y-intercept then? I can see by looking at the graph that it is at the point of 4.5 by the looks of it. So that means that ln a is equal to 4.5. Now we can rearrange this. Remember that the opposite of ln is exponential. So if we do e to the power of each side, we find that a is equal to e to the power of 4.5. Now, if we pop this into the calculator to 3 significant figures as the question wants, we find that a is equal to 90.0. So we found a now, we've done that and we've got it to 3 significant figures. Now we need to work out what k is. And we can see by comparing the equations again that k is equal to the gradient. So if we look at our graph here, we need to find the gradient of this straight line. And the way that we would normally do that is by drawing a nice big triangle out of the line. The bigger the better because it minimises errors. So I'm going to do that here then. I'm going to turn this into a nice big triangle. And the important thing to remember is that gradient is equal to the change in the y-axis divided by the change in the x-axis. So looking at the y-axis here, it starts up at 9.5 down to 4.5, and along the x-axis it goes from 0 to 10. So the change in the y-axis is 9.5 minus 4.5, and the change in the x-axis is 10 minus 0. That leaves us with 5 over 10, or we could say 0.5 or 1/2. But because we need it to 3 significant figures, let's write it as a decimal and add in those extra significant figures. So we're going to call k equal to 0.500. We're not just going to leave it at 0.5. Perfect, so there we go. So there's our A and our K. Now we need to find the population of rabbits on the island on the 1st of January 2020. So let's fill in our new information into our equation that they gave us. So now we can say that R equals 90.0 e to the 0.500t. And because time is counting from 2020, well, on the 1st of January 2020, time is just equal to 0. So if we substitute 0 in, we basically got e to the power of 0. And e to the power of 0 is 1. So that means that R is just equal to 90. So that means our initial population of rabbits, that's another way they could have asked it, is equal to 90. So now we need to predict the population of rabbits on the island of the 1st of January 2100. So let's go back to our equation. R equals 90.0 times e to the 0.5t. Well, in this year 2100, that means if we compare it to the initial date of 2020, then the time that's passed is 80 years. So we'd have to essentially do this 2100 minus 2020. So now we know that 80 years has passed, we can substitute in place of t 80. So we've got R equals 90.0 e to the power of 0.5 times 80. Now that gives me the enormous number of 2.12 times 10 to the 19. That's a lot of rabbits on this island, but that's our answer to C. And now we're asked to suggest a reason why this prediction may be incorrect, and it certainly sounds it because that's an enormous amount of rabbits. And this is an answer that will carry across to any similar question on this topic. Basically, there's no constraints on the number of rabbits that will fit on this island. What if physically that's more rabbits than will even fit on the island? Then obviously the model doesn't work. So another thing is over time, over this 80 years, there's normally fluctuations that take place. There might be diseases that come in, there might be climate change, there will likely be other factors that are going to impact on the population of rabbits that probably haven't been taken into consideration in this model. So that's a very standard answer. You can normally apply that to any similar type of question with little tweaks to make it specific to what the question's about. A landscape gardener designs a patio. The patio has a perimeter of p meters, and the area of the patio is equal to 100 meters squared. Here we're asked to show that p equals 100 over 3x plus 3 pi x. Now, really importantly here, and this carries across the whole of maths, when you get a show that question like this, just don't focus on what you're trying to show. Absolutely ignore it. I scribble it out with my students, just be like, ignore this is irrelevant, until literally the last line when I might want to tidy up what I found, or I might want to check that I have actually got it looking how they wanted it. So here, what I would do is I would just look at everything else in the question. I would look at the labelled diagram. I would see that they talk about the perimeter and they give us the area. And I would think, okay, let me just start by writing down what I can about perimeter and the area of this shape. And what you'll find in these show that questions is just by doing that maths, it will become clear how you eventually get to that show that. Okay, so maybe keep one random element in the background. You can see that we want P in terms of X only, but beyond that, it's not going to help us, okay? So let's get started here. Perimeter. Clearly, we need to work out the perimeter. So let's do that. So looking at this shape, I can see that the perimeter has essentially two semicircles and the two lengths, I guess, of that rectangle within it. So here I can see that I've got a Y on the top, got a Y on the bottom, and then I need to have a think about these two halves of a circle. Well, if I've got two halves of a circle, I've actually got a whole circle, haven't I? So what I can do is I can work out the circumference of that circle. I should know that the circumference can be found either using 2 pi r or pi d, depending on what you feel comfortable with and what data you have. Now I can see here that I know what the diameter is. I know that the diameter is equal to 6x. So using that fact, I can easily work out the circumference just by timesing the diameter by pi. So in total then, the perimeter is going to be equal to y plus that circumference of a circle, which works out as 6 pi x. So tidying that up, I get the perimeter equals 2y plus 6 pi x. Now, this is where you might want to glance one eye at what it is and you can see, that's p, but it's not the same. I can see that there's a y in this perimeter, but the show that doesn't have a y. Now, nothing to panic about, just carry on doing whatever maths we've been provided with. And we were told what the area is, so let's work out what the area of this patio is now. I can see a rectangle region to this, which timesing the base by the height gives me 6xy. And then again, I've got two semicircles which together just make up a circle. So I just need to say what the area of the circle is. And I should be very familiar with the fact that a circle has the area of pi r squared. So the radius is half the diameter, so that's 3x. So the area of the circle part is just pi times 3x squared. So the total area is 6xy plus, due to the fact we've squared the 3 and the x, we get plus 9 pi x squared. And from the question, we know that area is equal to 100 metres squared because they told that to us, so that's what we use. Now this equation also has a y in it, but we know what it's equal to. So what we can do is we can rearrange this equation now to find out what y is. So I'm starting off by just subtracting the 9 pi x squared, and then I'm going to divide through by the 6x to get the y on its own. So one at a time, 100 divided by 6x, and then minus 9 pi x squared over 6x. Now, I can tidy that up a bit once I do that. I can look for common factors. I can see that x squared and x both have an x, so I can cancel those. 9 and 6 can both divide by 3, giving me 3 over 2. 106 divided by 2, so I've got 50 over 3 there. So that gives me in the end y equals 50 over 3x minus 3 pi x over 2. So now I know what y is. I can go back to that equation for the perimeter that we had and simply substitute this in. That's all we need to do. So we've got p equals 2 times, and instead of y, I'm writing 50 over 3x minus 3 pi x over 2, and then plus 6 pi x. That gives us p equals 100 over 3x. Remember, we just times the tops because 2 is essentially 2 over 1. Minus, it just becomes 3 pi x, plus 6 pi x. And gather up the like terms here of the minus 3 pi x plus 6 pi x. And that leaves us with p equals 100 over 3x plus 3 pi x. And if we look back at our show that, you can see perfect. We have exactly what we were asked to find. So please, 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 if you get a show that, don't put too much emphasis on what you're being asked to show. Just think about what information you've been given in the question and use that. So now we're asked to use calculus to find the minimum perimeter of the patio and give your answer to the nearest metre. So now it's time for my next really important tip here. Time and time again, I see people, if they can't do the show that in part A, they just leave the entire question. And that is such a bad thing to do. This is 4 marks, 4 precious marks in this exam that you will be missing out on, that you can 100% do. Because the importance of the show that question is they give you the key to do the rest of the question. They've given you what you need to access it. So they're actually brilliant questions because they're not limiting you through the rest of the question. What you would need to do in this question is just use the equation that you showed in the previous part that they gave you to then do this next part. So the next thing to mention is this says using calculus. You should know what that means. Calculus means either using differentiation or integration. Now in this particular question though, they talk about the minimum, and that narrows us down to know we need to differentiate and put it equal to 0. Same if they said maximum. So let's remind ourselves now of what the equation for p is. P equals 100 over 3x plus 3 pi x. And what we need to do is we need to differentiate this with respect to x. Now when we have 100 over 3x, we need to remember that's the same as 100 over 3 times by 1 over x. And we really do need to know that 1 over x is the same as x to the power of minus 1. Then we've got the plus 3 pi x. Pi is just a constant, just like the 3. Don't try and differentiate that. I see people do that all the time. So differentiating this, remember we multiply through by the power, and then we subtract 1 from the power. Using our classic rule, never ever forget this. You should know this inside out now. But the power in this case is minus 1, isn't it? So we need to multiply through by the minus 1, giving us minus 100 over 3. Then if we subtract 1 from the power, we get x to the minus 2. Then we've got plus 3 pi x. We've said before, we'll say it again, whenever we differentiate an x term, the x just goes away. And that leaves us with just 3 pi, because pi is a constant, it's a number just like 3. So now we've done that, we can remember we're looking at a minimum. And in a minimum, this differential is equal to 0. So here we've got minus 100 over 3x squared plus 3 pi is equal to 0. You'll notice I've rewritten that negative power back as a fraction, just because I think algebraically it's easier to use. So rearranging this now, let's chip away at it. I'm going to say that 100 over 3x squared is now equal to the 3 pi. Then if I multiply through by that x squared, I get left with 100 over 3 equals 3 pi x squared. Now let's get the x squared by dividing through by 3 pi. And we end up getting 100 over 9 pi. So therefore, x will be equal to the square root of 100 over 9 pi. See, when we square root things, it can technically be positive or negative, but because we're talking about lengths here, that is not important. Now looking at this question, you can see we're not being asked to find the x value, the minimum value of x. We're being asked to find the minimum perimeter of the patio. So to do that, we need to go back to that original equation for the perimeter. So we know that p equals 100 over 3x plus 3 pi x. And so what we need to do is just substitute our value of x into that equation. It really is as simple as that, but do make sure that in an exam, you almost go back and read the question again after you've worked out the first thing, because I think it'd be very easy to just leave it there and miss out on those last valuable marks. So then, P is going to be equal to 100 over 3 times root 100 over 9 pi, plus 3 pi times root 100 over 9 pi. So at this point now, we're just going to pop that into our calculators, and that gives me a perimeter there equal to 35.449 metres. Now again, we just go back, read the question one last time. I can see that they want it to the nearest metre. So I can see that's going to round down to simply 35 metres. And so that is our final answer there to get our 4 marks. There we go, all done. A student threw a fair dice 25 times. After each throw, they record the number on the dice. The student wants to model the number of times that the dice lands on a 6. Here we're asked to write down the distribution used to model the number of times that the dice lands on a 6. So looking at the information we've been given, I can see that we have this fixed number of trials. So we could say that n is equal to 25. At the same time, I can see we have a probability of this event happening too. Because this is a fair dice, we know that the probability that it lands on a 6 will be equal to 1/6. Now, because we know n and we know p, we can say that this is a binomial distribution. So when it comes to drawing a binomial distribution, the general form is you have an x with a little squiggle, and then a b, and then in brackets n and p. So in this case, we've got x squiggle b, and in the brackets we've got 25 and 1/6. And that is your distribution. Now we're asked to give 2 reasons why the number of times the dice lands on 6 can be modelled using this distribution. And this is a very common question. It's one that we just need to learn the facts of, and then we get some easy marks. So this is perfect for a flashcard. I'm going to tell you 4 things you could say, that any 2 of those would get you your 2 marks. So one of them is that we have this fixed number of trials, just 25 trials. We can also see that there are only 2 possible outcomes. So in this case, we can only get a 6 or not a 6. We can also see that there is a fixed probability of success. We know that because it's a fair dice, the probability of getting a 6 is 1/6, and that won't change. And finally, the trials are independent of each other. Once you throw the dice one time, it doesn't make it any more or less likely that you will get a 6 the second time. And those are 4 things that are always true when it comes to choosing a binomial distribution. So if you didn't know those, turn it into a flashcard now and get learning them, because that's 2 easy marks on your stats paper. Here we're asked to find the probability that the dice lands on 6. And firstly, we're asked to find the probability of that happening exactly 25 times. Now let's remind ourselves of the distribution. We know that x is a binomial distribution where n is 25 and the probability is 1/6. So there's 2 ways that we can work this one out. So we can simply do it mathematically. So the probability of it landing on a 6 26 times in a row, so the probability of x equaling 25, is going to be equal to 1/6, so that event happening 25 times in a row. So 1/6 to the power of 25. And of course we can put this into the calculator, and in that case I end up getting 3.52 times 10 to the minus 20. However, we can also use our calculators. So go to the statistics function. In this case we want binomial PD because we're looking for when it's equal to something. Go to variable. X in this case is 25 and n will be 25 due to our distribution, and the probability is 1/6, again due to our distribution, okay? So probability, I'm going to put in 1/6, and then I'm going to press execute. Now that then gives me my probability, and as you can see here, it's exactly the same as what we got in our calculators. by just doing 1 over 6 to the power of 25. So for this particular question, either of those methods would work. Now let's have a look at working the probability of the dice landing on a 6 at least 5 times. So let's start off by writing what we need to find. So we want the probability that x is bigger than or equal to 5. Now, although we have our calculators, we do want to show some level of understanding and method here. So because the binomial distribution is a cumulative one, let's rewrite this as 1 minus the probability of x being less than or equal to 4. Because think, if it's going to be 5 or more, then we could take the probability of 1, everything happening, and subtracting the probabilities of it not being bigger than or equal to 5. So the probabilities of it being 4, 3, 2, 1, 0. And that's what this does. So let's have a look here at the calculator. And let's see here that if we go to distribution again, this time to the binomial CD, which means cumulative, which we use whenever we have a less than. And in this case, you can see that x is going to be 4 in this case, because that is what we settled on. 25 is still our n, and 1/6 is still our p. So now that we've got all of those, we press execute, and we end up finding the probability of x being less than or equal to 4. And that's always what that binomial CD is going to do, okay? It's giving you the probability of something being less than or equal to that number. So here then, so probability that x is bigger than or equal to 5 is equal to 1 minus 0.5937. Now, if I put that into the calculator, I end up finding that the probability that x is bigger than or equal to 5 is going to be equal to 0.4063. And that is our final answer. X and Y are two events. It's known that probability of x is equal to 0.3, the probability of y equals 0.25, and the probability of not x and not y is equal to 0.6. Here we're asked to work out the value of a, which as you can see in this diagram is the probability of x and y. So let's just summarise out this information. We know that the probability of x is equal to 0.3, the probability of y is equal to 0.25, and the probability of not x and not y equals 0.6. So let's draw out our diagram and just think of what the information we know is represented by on the diagram. So, of course, we've got this bit in the middle, this A that we're being asked to find. And the probability that not x and not y is equal to 0.6 is representing this region outside of our circles. So let me just shade this in now, just so we know what that 0.6 is referring to. So it's this outside of the circle region. As we know that total probabilities of all the options always adds up to 1, we can work out what this other probability is, this probability of it being x or y. So we're simply going to do that by doing 1 minus 0.6, and we get 0.4. Now if we think of the rest of the information that we have, so the probability of x is 0.3. Now we also know the probability of y is 0.25. Notice when I shaded both of these, they overlapped. And for that reason, taking the probability of x and adding the probability of y isn't going to equal the probability of x or y. We have to subtract that overlapping region to get that. Because as you can see, they're sort of covering each other twice. So we can say that the probability of x plus the probability of y minus that overlapping region will equal the probability of x or y, so that 0.4. So if we substitute these numbers in, we get 0.3 plus 0.25 minus a equals 0.4. Now that gives us 0.55 minus a equals 0.4, and therefore we get that a equals 0.15. and that is the probability of A. So next up, we're asked to determine if the events of X and Y are independent. So there's a certain rule we need to know for independent events. We need to know that the probability of X times by the probability of Y is equal to the probability of X and Y. And that's only true, that statement, if the two events are independent. So let's take 0.3, the probability of X, and multiply it by 0.25, that probability of Y, and see what we get. So putting that into the calculator, I get an answer equal to 0.075. So if we compare that to what we just calculated in A, which was the probability of X and Y, which was 0.15, we can see that they are not the same as each other. And as a result of that, we can say that the events X and Y are not independent. And so that is our answer to part B. A teacher wanted to investigate how long their students were studying for class tests. The teacher asked all the students in his lesson how long they spent studying for a maths test. The teacher then recorded this information in the table below. The midpoint of each class was represented by X, and its corresponding frequency was represented by F to give. The sum of Fx equals 681.5, and the sum of Fx squared equals 21,786.75. Here we're asked to use linear interpolation to find an estimate for the median time spent studying for the class test. So the first thing we need to do here is to see how many different students were asked. So I can see if I add up all these frequencies, I can see I had 27 students. Now, the median refers to the middle. So here we need to think, what if we've got 27 different students? If we lined them up in order of size, which student is our middle student? And so if we do 27 divided by 2, we can see that that's going to be the 13.5th value. Now looking at our table, you can see I've boxed off the one, which has the amount of time studying to be between 9 and 19. The reason for this is that there are 14 people within this interval. And so that 13.5th person is lying within that first 14 people. So what we need to do is to work out, well, what is that median amount of time studying? And I've got a really handy little trick that will help you do this. So I'm going to draw a line, and somewhere sort of in the middle, I'm going to do Q2, which is going to be our median value. Now looking at this interval here, the lowest number is 9. However, the lower value will actually be 8.5. Because if you look here, you can see that we're just rounding up or down each time. There's this little amount in between these numbers that we need to account for. So we're essentially doing the lower bound of 9, and we'll do the upper bound of 19. And that's where we've got this 8.5 and our 19.5, which are going to be our smallest possible value of the median and our biggest possible value of this median. So now we're going to do something similar on the bottom, okay? We're going to say, well, that median value corresponded to the 13.5th value, and we got that by halving the 27. Now within this little interval of this 14, the lowest number would be 0 and the highest number is 14. So we're looking at how many people are contained within that interval. So now this is our little trick. So this pink line I've done here, the length of that would be Q2 minus 8.5. And we're going to divide that by this bigger line here, this 19.5 minus 8.5. And we're setting that equal to the equivalent on the underside of this line. So we've got 13.5 minus 0, and then divided by 14 minus 0. So it's like the short bit divided by the long bit equals the short bit divided by the long bit. So now we can simplify this. 13.5 minus 0 is just 13.5, 14 minus 0 is just 14, and 19.5 minus 8.5 is just 11. So now that we've done this and we've simplified this, all we need to do is just rearrange this to get what our median Q2 is. So Q2 equals 13.5 over 14 times 11 and then plus 8.5. And popping that into the calculator, I end up getting 19.1 if I round that to one decimal place. You could round it to a different amount. So long as the answer is correct, you get your marks. Now, this is a really handy method of linear interpolation, and we can use that to find the upper quartile, the lower quartile, the median. In fact, different deciles and things as well. This method would still work. This is your linear interpolation method. Estimate the mean and standard deviation of the data. So we should know that to calculate the mean of a data set like this, the mean is going to be the sum of fx divided by the sum of our frequencies. Now, of course, in this question, they told us what the sum of fx is. We don't need to do that ourselves, thankfully. And so that is 681.5. And the sum of the frequencies, we already worked that out to be 27. So the mean is going to be 681.5, and that's going to be divided by 27. I'm popping that into the calculator. I end up getting 25.24 to 2 decimal places. Again, the amount you round, it's up to you. They haven't said how much to round by, but just make it clear how much you have rounded by putting a little 2 decimal places or 1 decimal place next to it. So now we need the standard deviation. So to work out the standard deviation of a data set like this, we need to do the square root of the sum of fx squared divided by the sum of f, and then we subtract from that essentially the mean squared. So we subtract the sum of fx over the sum of f, all squared. So here we know what the sum of fx squared is. We were told that on the previous page. So here we've got the square root of 21,786.75 divided by that 27. And then I'm going to subtract the 681.5 over 27 squared. Now, if I put that into the calculator, that will do all the work, and I end up finding that the standard deviation equals 13.03 to 2 decimal places. 20 people were asked their height and weight using opportunity sampling. The heaviest person in the sample weighed 85.2 kilos, and the lightest person in the sample weighed 61.3 kilos. Give an advantage and a disadvantage of using opportunity sampling. So opportunity sampling is all about getting some data as easily as possible. So perhaps we just hand out a survey to some friends and family, or we just ask the next few people that come out of a shop. So the advantage to this is it's very easy to carry out. Another advantage is that it's going to be very cheap to carry this out. So not expensive is another advantage you could say. Pick one of those as your option. Both of them would get you one of the marks here. Our second mark comes from giving a disadvantage. So the main disadvantage here is that it's unlikely that the data you get will be representative. And for this reason, opportunity sampling often isn't ideal. Okay, so next up, a linear regression line of weight against height was found using the data received from these 20 people. So we get W equals 36.4 plus 0.25h, where h is the height measured in centimetres and W is the height measured in kilograms. Here we're asked to give an interpretation of the gradient of the regression line. And the gradient here is that 0.25. Well, this is a common question, and the format of this answer is how we want to answer these questions. So for every 1 centimetre increase in height, the weight is going to increase by 0.25 kilograms. And so we just need to look at those variables, think about what units they're in, and use those to explain what the gradient means. Next up, we're asked to suggest how we could improve this model. So at the minute, we know that this only came from 20 people. Now, in sampling and in statistics, that is a very small sample size. So we could improve this model by using a larger sample size. And that's often going to be our answer in statistics as to how we could improve any modelling we've done. This model is not always appropriate. Suggest why. Well, to answer this, let's remind ourselves of what that model was, okay? So we were given the model that stated that W is equal to 36.4 plus 0.25 H. Now the issue with this is at some heights, it's going to give very unrealistic weights. In fact, when H equals 0, we still get a weight. And that is clearly an issue because if someone has a height of 0, well, they don't exist for a start. They're certainly not going to have a weight. So that is going to be our answer here. It's not always appropriate, and we can see that because it gives weights for unrealistic heights. For example, somebody that had a height of 0 centimetres, for instance, would still have a weight of 36.4 kilograms. So whenever you get a question like this, testing the appropriacy of a model, just think, at certain variables, would it make sense? So now for part E, using the linear regression model, work out the expected height of a person who weighs 120 kilos. Comment on the validity of your answer. So here we know that W equals 120. And using the model of W equals 36.4 plus 0.25 H, we can substitute that in. That gives us 120 equals 36.4 plus 0.25 H. Now, if I rearrange this now and I subtract the 36.4 from both sides, I get 83.6 equals 0.25 H. Now, if I divide through by the 0.25, I'm left with H equals 334.4 centimetres. Now, we're asked to comment on the validity of our answer. So in order to talk about this, let's remember what the heaviest person was in our data set. And we know that the heaviest person weighed 85.2 kilos. That was given right at the beginning of our question. So here where we're being asked about someone that weighs 120 kilos, this is outside of our data set. Now this means that we have had to do extrapolation. And extrapolation is always less likely to be valid because we're having to assume that this relationship holds for extreme values too. So we'll finish up our comment on validity by explaining that we've extrapolated outside of our data set and therefore the results are less likely to be valid. Before any training, a sales company converts a sale in 1 of every 15 calls. After the staff of the sales company take a training course, the company believes more calls will convert to sales. The company collects data on the next 40 calls and 3 of them converted to sales. Test the company's claims to the 5% level of significance that the training has increased sales conversions. State your hypothesis clearly and include a test statistic in your answer. So in this particular case, our test statistics is going to be the number of calls which convert to sales. So that's the first thing we're going to write down. We're going to call that X, and we're going to say that X is the number of calls which convert to sales. And when it comes to deciding what distribution to use, we can see that we know that there is a sale in 1 of every 15 calls. So we can say that the probability of a sale is 1 out of 15, or 1/15. And we can see that the company collects data on the next 40 calls. So we have a fixed number of trials. We have n equals 40. Now, what this means here then is that we have got a binomial distribution. So let's write that up now. The general format of a binomial distribution is x with a little squiggle b and then np. So in this case, that would be x squiggle b and then 40 and 1/15. So we've got our distribution. In terms of our hypotheses, our null hypothesis will just be that nothing has changed. So the null hypothesis states that the probability is still equal to 1/15. The alternate hypothesis, though, we need to look at the change we expect to happen. And we're saying that after this training course, we want more calls to convert to sales. So H1 is that the probability is bigger than 1/15. So there we have it. We have our hypotheses, we have our distribution, and our test statistic. Here we want the fact that the probability that x is bigger than or equal to 3. And that 3 has come from the fact that the company collected data on the next 40 calls and 3 of them converted to sales. We always want to make sure that we keep the direction of that inequality there in the same direction as our alternate hypothesis. So our alternative hypothesis stated the probability is bigger than 1/15, and so we say that we're looking for the probability that x is bigger than or equal to 3. So now let us go to our calculator. We're going to go to distribution, and we want binomial CD. Now here, because we're looking for the probability that x is bigger than or equal to 3, we actually want to find 1 minus the probability that x is less than or equal to 2. And so that means on our calculator, we want our x to be 2. We're going to want our n to be 40 from our distribution. And we're going to want our p to be 1/15, again from our distribution. So if we press execute now, we find that that probability of x being less than or equal to 2 is 0.4961. So we can fill this in now. So we've got the probability that x is bigger than or equal to 3 is equal to 1 minus 0.4961. And that ends up giving us a probability of 0.5039. So we're asked to compare this now to the 5% level of significance. So clearly, as 5% is equivalent to 0.05 as a decimal, we can see that 0.5039 is bigger than 0.05. So we need to know this statement off by heart, okay? We need to know that if our probability is bigger than that 5% level, then we need to say that there is not enough evidence to reject the null hypothesis. And that means that there is not enough evidence to decide that this sales training has increased the number of calls that convert to sales. And so we always need to give a conclusion at the end. First, give the generic statement about whether there is or isn't evidence to reject the null hypothesis, but then bring it back to the specific example of the question and make it clear what contextually has happened. So there we have it. That's how we do these. I hope that makes some sense.
Ouch! This is why in some videos I'll explain scratches.